Okay, so I'm going to give you an introduction into polar coordinates, which is section H.1, right from the ebook. So on that note, let me share the ebook, and you can go into your ebook. And you want to go to appendixes. So I'll click on appendixes. And polar coordinates is right here. It's H. Incidentally, Appendix C has a trigonometry review, if you ever need to use that. It seems you're pretty strong on trigonometry, but it's there. But let me click on polar coordinates. And we'll talk about curves in polar coordinates. Okay, so is everybody okay in finding this appendix H in your ebook? Give me a thumbs up if you have that on your computer. Appendix H. Thank you, John. Thank you, Tyree. Okay, all right. So a coordinate system represents a point in the plane by an ordered pair of numbers called coordinates. And we use Cartesian coordinates, and I'm just reading from the introduction, which Cartesian coordinates are directed distances from two perpendicular axes. Okay. Here we describe a coordinate system introduced by Newton called polar coordinate system, the polar coordinate system. So for the polar coordinate system, we don't have an X and a Y. We don't have an X and a Y coordinate. We have, as you can see in figure 1 here, we have an R and a theta coordinate. R stands for radius, and theta stands for angle. So to get a polar coordinate, and the polar coordinate is R theta, what you do is you measure from the positive x-axis your angle, an angle theta. And this is standard in trigonometry. You measure your angle theta from the positive x-axis. And you measure an angle theta, and then at that angle theta, you move out a radius r from the origin. And that's going to be, so from the angle, at angle theta, you move out from the origin an angle r. And so that gets you the point, the polar coordinate r theta at point P. Okay. All right. Are there any questions on figure 1 from the ebook? All right, well, let's move down a little bit here. In figure 2, what they have drawn are two polar coordinates. One polar coordinate is r theta. The other polar coordinate is negative r theta. Okay. So take a look at that. Take a look at that, and let's see if we can make sense of what's going on here. So r theta, you should be comfortable with that, that polar coordinate. But what's negative r theta? Well, with polar coordinates, you can have negative radiuses. You are allowed to have negative radiuses. So what happens here with negative r theta? So well, let's do the r theta polar coordinate first. So to get at that point, r theta, you measure an angle theta and you move forward a distance r. But to get the negative r theta polar coordinate, there, what you do is you measure an angle theta from the positive x-axis, but then you move backwards a radius r. You move backwards a radius r. So you're not moving, you measure an angle theta, you're not moving forward a radius r, you're moving backwards a radius r, and that gets you to negative r theta. So with polar coordinates, you can have negative radiuses. Okay. Are there any questions on figure 2? I want to make sure we're all comfortable. You have to let me know. Okay. Notice in the reading here, it says, notice that negative r theta represents the same point as r comma theta plus pi. So this is something also different about polar coordinates. Polar coordinates are not unique. With Cartesian coordinates, when you have a point in the xy plane, the xy coordinates for that point are unique. Only that point has those unique xy coordinates. But with a polar coordinate, you can have, with a point, using polar coordinates, a point can have multiple representations. So like negative r theta, like that blue point there in figure 2, negative r theta is a polar coordinate for that point, but also the point theta plus pi, or r and theta plus pi is a polar coordinate. Because if you move out an angle theta plus pi, and then look in the direction of theta plus pi, look in that direction. So pretend you're at the origin. You're at the origin, and you're looking in the direction of theta plus pi. Well, if you move forward a positive distance r, that's going to get you to the same point as negative r theta. Okay, so negative r theta represents the same point as r theta plus pi. Okay, so that's one difference between polar coordinates and Cartesian coordinates. Polar coordinates are not unique to a point. You could have an infinite number of polar coordinates for a point. Okay, are there any questions on that? Okay. So in example 1, it says plot the points whose polar coordinates are given. Okay. So let's see here. All right, the first polar coordinate is 1, 5 pi over 4. Okay, well, 5 pi over 4 is how many degrees? Who can chat out how many degrees 5 pi over 4 is? Well, let me ask you this. That's right, 225 degrees. That's right, Robin. Thank you. So pi over 4 is 45 degrees, right? So 5 pi over 4 would be 5 times 45 degrees, and that's 225 degrees. So here in the picture, let me just see one thing here. Here in the picture for part A, what they do is they measure a 225 degree angle from the positive x-axis and then move forward a radius of 1. And that gets them 1, 5 pi over 4. So I'm assuming you're looking in your ebook as well, okay? All right, and then for the second one now, you have second polar coordinate is 2, 3 pi. 2, 3 pi. So that means, well, pi is 180 degrees. So 3 pi is 540 degrees. So from the x-axis, you go out, you measure 3 pi or 540 degrees. Well, one rotation is 360 degrees. So you have to move out another 180 degrees to get to the 3 pi. So that 3 pi is 540 degrees. And then from the origin, you look in the direction of 540 degrees. You look in that direction, and you move out a positive radius 2, and you get 2, 3 pi. All right. Are there any questions on the second polar coordinate 2, 3 pi? All right. Well, then let's move to C here. For C, you have the polar coordinate 2, -2 pi over 3. Well, okay, pi over 3 is 60 degrees, so -2 pi over 3 would be -120 degrees. So for this part C here, in the third picture in figure 3, from the positive x-axis, you go clockwise, right? You go clockwise because it's a negative angle, and you go out -120 degrees clockwise. And then you look in that direction and move a radius of 2. Are there any questions on the third one? The third polar coordinate, 2, -2 pi over 3. All right, all right. Well, and then finally, for D, you have -3, 3 pi over 4 as your polar coordinate. So pi over 4 is 45 degrees. 3 times 45 degrees is 135 degrees. So you go out 135 degrees in picture 4 there. So it's a positive angle, so you move counterclockwise. You move out from the x-axis. You measure an angle of so from the positive x-axis, you measure an angle of 135 degrees. That puts you in the second quadrant. But then you look in the direction of 135 degrees, but since it's a negative radius, -3, you move back -3. Or I'm sorry, you move back 3 units. Hence, you get -3, 3 pi over 4. Okay, so are there any questions on these particular graphing these polar coordinates? Please let me know if you have any questions before we move on. All right, of course, in WebAssign, what you'll see, they'll give you polar coordinates, and then they'll give you like 4 choices. And, 4 choices, you have 2 tries to get the right choice, so, multiple choice. Okay, now we move on here. We move on to, Formula 1 here. So of course, just like you learned in trigonometry, the cosine of theta is x over r. The sine of theta is y over r. Well, this means that x is r cosine theta and y is r sine theta. So therefore, r squared equals x squared plus y squared, and tangent theta is y over x. So these are all formulas you've seen in trigonometry. But we need the formulas because sometimes what we want to do is we want to convert from a polar coordinate to a Cartesian coordinate. So for instance here, in example 2, they want you to convert the polar coordinate 2, pi over 3 from polar to Cartesian coordinates. Okay, well, your radius is 2, and your angle is pi over 3, so x is r cosine theta, y is r sine theta, And so you will get the x-coordinate of 1 and a y-coordinate of √3. You know that the cosine of 60 degrees is a half, and the sine of 60 degrees is √3/2. So the coordinate 2, the polar coordinate 2π/3 has Cartesian coordinates 1, √3. Okay, and okay, so that's converting a polar coordinate to a Cartesian coordinate. Similarly, well, are there any questions on that particular problem? Take a moment to look at it. Okay, well, if there's no questions on that, let's move to example 3. Here we have a Cartesian coordinate, 1, -1, and we want to find the polar coordinate. So 1, -1, I know that is in the 4th quadrant, right? So the radius, of course, you just take the square root of x² + y², that gets you √2. And then the tangent of theta is -1. So for the angle, you can choose -π/4 or 7π/4. So one possible answer for a polar coordinate for this point is √2 -π/4. Another possible answer is √2 7π/4. All right, so let's see if you have any questions on that one, that particular example. Are there any questions at all? Okay, well then let's move on to example 4. We'll be doing a few of our own little examples, but I just want to be sure you're comfortable. So example 4 gives a polar equation. A polar equation. What curve is represented by the polar equation r = 2? So you're used to y = a function of x. Okay, but now we have r is a function. Well, r is a function of theta, formally, but r = 2. The curve consists of all points which with radius = 2. So theta could be any angle. So the only thing that's going to satisfy this polar equation is a circle whose radius is 2. Because all the points on the circle have different angles, different thetas, but the radius is always 2. And so if all you care about is a polar equation where the radius is 2, it has to be this pink circle. One moment, let me move the phone. Hello. Okay, sorry about that. Are we okay on this problem? Are we all right with that? Okay. Well, all right. Let's look at another problem. Sketch the polar curve theta equals 1. Sketch the polar curve theta equals 1. All right, well, so here all you require is that theta equals 1. You're not getting any information about the radius. It's going to be, the theta equals 1 curve is going to be a straight line. Every point on this line has an angle of theta equals 1. Now, 1 is in it's radian measure, right? Theta equals 1. So like, you know, you're used to seeing theta equals pi over 4 or theta equals pi over 6. You're used to seeing those kind of angles. But pi over 4, you know, that we could approximate that angle by, you know, we could convert it to a decimal. Pi divided by 4. We don't normally do that, but pi over 4 is 0.785. So theta equals pi over 4 in radian measure is like theta equals 0.785. Well, theta equals 1 is going to be a little more than 45 degrees, right? Because 1 is greater than 0.785. In fact, let me see. Let me just do one thing here. If you were to take that 1 in radian measure and multiply it by 180 degrees over pi, 180 divided by pi, the reason I do that is I want to convert 1 to degrees. That's going to be 57.296 degrees. So that looks about right, looking at that angle there. That looks about 57 degrees. But every point on the line has an angle of 1. If you were to measure each angle for each point, it's going to have about 57-degree angle, but the radius varies. Okay, 1, 2, 3, -1, -2, -3, and so forth. It traces out a line. Okay, are there any questions on that? Any questions at all? Please let me know. Okay, all right, let's continue on. Let's continue on here. All right, here's something. We want to sketch a curve with example 6. We want to sketch a curve with the polar equation r equals 2 cosine of theta. R equals 2 times the cosine of theta. Well, and then for part B, we want to find a Cartesian equation for this curve. So in this example, they make a table. So this example is not as easy as, you know, the previous 2 examples. So whenever you learn, you know, when you first started learning about graphing functions, you know, y equals a function of x. You know, like if you had to graph y equals x squared. Well, what did you learn? What did you do? You picked some different values of x, and then you know, nice values of x, and then you found the corresponding values of y and plotted the coordinates, and then that allowed you to graph y equals x squared. Okay, whenever you started learning about functions of x, you would pick values of x until you had enough so you could get an idea what the function looked like. It's the same thing with polar functions. In polar functions, r is a function of theta. And in the table here, what they've done is they've picked some values of theta, some angles, such that these, and then for each angle, each value of theta, they found a corresponding radius. and then they plot the polar coordinates on the picture here, and it's going to trace out a circle. So what I'd like you to do is look at the table for a minute and study the picture, and let's see. I want you to just spend a few minutes looking at it, and then I'm going to come along and explain it, and hopefully you'll be okay. But just take a few moments to look at the table in this example 6 here from the ebook, and look at the picture. Okay, so for the first coordinate, of course, when theta is 0, so in this figure here, figure 8 from example 6, r equals 2 cosine theta. When theta is 0, well, the cosine of 0 is 1, so 2 times 1 is 2. So they start off at 2, 0. The polar coordinate has radius 2, angle 0. 2, 0 is right on the x-axis there. And then they say, okay, well, let's pick another angle. Pi over 6, that's a nice one. The cosine of pi over 6 is root 3 over 2. So 2 times root 3 over 2 is root 3. And so pi over 6, root 3 pi over 6 is their next point. So you from the x-axis, they measure 30 degrees, and then you move forward a distance of root 3, which is about 1.7. And then pi over 4, that's a nice angle. Well, cosine of pi over 4 is root 2 over 2. 2 times root 2 over 2 is root 2. So the next polar coordinate is root 2 pi over 4. And so they measure out an angle of 45 degrees and move out a distance of root 2, which is about 1.4. It's a shorter distance, right? And then pi over 3 is the next angle. Pi over 3, cosine of pi over 3 is, let me see, a half, right? So 2 times a half is 1, so 1 pi over 3 is the next polar coordinate. So you move out an angle from the x-axis, you measure 60 degrees and move up a distance of 1. And then finally, pi over 2, that's the next angle, that's 90 degrees. Well, the cosine of 90 degrees is 0, so your next polar coordinate is 0 pi over 2. So that's like being, from the origin. You're always moving from the origin, right? So from the origin, you look up 90 degrees, but don't move anywhere, and that puts you right at the origin. Okay, so again, we started out at the polar coordinate 2, 0. That means an angle of 0 degrees keeps you on the x-axis. You move out from the origin forward a radius of 2. The next polar coordinate, root 3 pi over 6. From the x-axis, you measure an angle of 30 degrees and then move out from the origin a distance of root 3. You move forward root 3. that's going to be, moving out about a distance of 1.7. The next polar coordinate of root 2 comma pi over 4. From the x-axis, you measure an angle of 45 degrees, and then you move out from the origin a distance of root 2, which is 1.4. And then the next angle, 1 pi over 3, from the x-axis, you measure an angle of 60 degrees, and then move out forward from the origin a distance of 1. Okay, and then finally, you have the 0 pi over 2 coordinate, polar coordinate. So from the origin, you measure an angle, you measure an angle of 90 degrees, but then you don't move at any distance, so you're right at the origin. Are we okay with the first 5 polar coordinates, how to plot them? Are we okay with that? Okay, all right. Well, now we continue. So after 2 pi over 2, they pick 2 pi over 3. That's 120 degrees, right? 2 pi over 3 is 120 degrees. So from the positive x-axis, you measure 120 degrees, and then you look from the origin, you move back a distance of 1. You move backwards a distance of 1, because 2 times the cosine of 120 degrees is 2 times negative a half, that's negative 1. 3 pi over 4, the next angle is 135 degrees. So you measure from the positive x-axis 135 degrees, but 2 times the cosine of 135 degrees is 2 times negative root 2 over 2. So you move backwards negative root 2. Okay? And that gets you that polar coordinate of negative root 2, 3 pi over 4. Okay, and you just keep going. You keep going. And the final point at angle pi, the 2 times the cosine of pi is 2 times negative 1, that's negative 2. So you look in the direction of 180 degrees, okay, from the origin, but then you move backwards 2 units, and that gets you at pi negative 2. Pi negative 2, or negative 2 comma pi, that polar coordinate is the same as the coordinate 2, 0. So you've completed the circle. You've now completed the circle, and you don't need to pick any more coordinates. You don't need to pick any more angles to determine what this polar curve looks like. It's going to be a circle. It's going to be a circle centered at 1, 0 with with radius 1. But are we okay with this polar curve, how they got the polar curve? Are we all right with that? All right. Well, they also, this is a circle that we ought to be able to find the Cartesian equation for. So what they do is they say, okay, well, r equals 2 cosine of theta. That's the polar equation. So you can replace the cosine of theta with x over r. So r will equal 2x over r. Hence, r squared will equal 2x. So r squared equals x squared plus y squared. Okay, but we don't have but for a Cartesian equation, we need x and y. We need x and y. Well, let me just see here. So 2x equals then x squared plus y squared. X squared plus y squared minus 2x equals 0. And you can complete the square to get the Cartesian equation, x minus 1 quantity squared plus y squared equals 1. And that's going to be your hold on here. That's going to be your Cartesian equation. And that does represent an equation, Cartesian equation, for a circle with radius 1 and center 1, 0. And you can see based on the polar curve, that is a circle centered at 1, 0 with radius 1. Okay, are there any questions on that? Any questions at all? All right. So I want to continue more. I want to do examples of my examples, and then I'm going to let you work a little bit. So let me stop sharing for the moment with this, and let me bring up the examples. Okay. Okay, and let me give you a moment to copy now. We're going to do 2 examples right here, but let me give you a moment to copy down this first example. Okay, all right. So in this problem, we want to find the polar coordinates r theta of the point with Cartesian coordinates -1, √3, where for part A, you're restricting theta to be between 0 and 2 pi, and the radius is greater than 0. And for part B, you're restricting theta to be between 0 and 2 pi, but radius is less than 0. So the reason we have to restrict the angle, and you will see this in WebAssign as well, you have to restrict the angle because otherwise, you know, the polar, there are an infinite number of polar coordinates for the same point, you know, in the xy plane. So you have to restrict the angle so that, you know, so that you can type in an answer. But the best way, I think, to always do these problems is to draw a picture. Okay, so if we go right to the solution, which I'll do here. Okay, go right to the solution. What I've done is I've drawn a picture of the Cartesian coordinate -1, √3. Okay, this is your Cartesian coordinate. Now, of course, for that Cartesian coordinate, we need to figure out what theta is, right? And what the radius is. Well, this is just like you do in trigonometry. You create a right triangle, you know, and you create a right triangle, and you know that since the x is -1 and the y is √3, the radius here has to be 2. So if I just, maybe I'll just put this in here. You have a right triangle. Okay, whose sides are, you know, that leg is 1. This leg is √3. And the radius here, the hypotenuse, is 2. Well, you know that's a 30, 60, 90 right triangle. And so the angle opposite √3 would be pi/3, 60 degrees. Therefore, the angle that you need to get the polar coordinate is going to be the 120 degrees, because the 60 and the 120 add up to 180. So this means the angle is 2 pi/3, which is 120 degrees. Okay. The radius is 2. So for part A, you wanted the radius to be 2, and you wanted the angle to be between 0 and 2 pi. So that's part A. Are there any questions on part A? Okay, for part B, we want the radius to be negative. Okay, well, what I do there for part B is I say, okay, well, I want to be, hold on, one moment. Okay, so what we have to do is we have to find an angle We have to find an angle. And once we have that angle, we move backwards, and that gets us to the Cartesian coordinate. Well, if you take the 2 pi over 3, the 120 degrees, and then add 180 degrees, that gets you to 5 pi over 3, or 300 degrees. So if you have your 300 degrees here, but yet you move backwards a distance of 2, that gets you to -1√3. Hence, the polar coordinate -2 and 5 pi over 3 would be a polar coordinate that gets you to the Cartesian coordinate -1√3. It gets you to that point, but with a negative radius. How many actually find the drawing a little picture to be helpful to answer this kind of question? Thank you, John. Thank you, Tyreek. Thank you, Robin. I agree so much. I agree so much. And that's it. So a little note here. There are infinite polar coordinates for a point. Polar coordinates for the Cartesian coordinate -1√3 are, for example, here I've given, you know, like for part A, you know, you have polar coordinate 2 pi over 3, but you could also put in, you could have put 2, well, since they're restricting theta to be between 0 and 2 pi, your only answer here would be 2 pi over 3. But just remember, the polar coordinates 2, 8 pi over 3, and to -4 pi over 3, you know, would also be, they're also polar coordinates that get you to the same point. You're just you're rotating 360 degrees. With the 2 pi, you're doing a revolution in the counterclockwise direction. With -2 pi, you're doing a revolution from 2 pi over 3 in the clockwise direction. Okay, so hopefully you're all comfortable with that. Are there any questions at all before we move on? All right. Has everybody had a chance to copy the example down? Okay. Maybe I'll pause for a moment to make sure of that. Okay. Well, why don't we move on to the next example then? Okay, take a moment to copy this example down. Okay, all right. So in this problem, we want to find the polar coordinates of the point with Cartesian coordinates 1, -3, where r, in part A, r is positive, theta is between 0 and 2 pi, and in part B, r is negative, and theta is between 0 and 2 pi. So what's interesting about this problem is it's not you know, the Cartesian coordinate 1, -3 is not a nice point, right? It's not a nice point. It doesn't have a nice angle to go with it, okay, which is different from the first problem you did. So again, what I recommend is drawing a picture to help you. So let's go to the solution. All right, everybody has this copied okay? Okay. Nice picture here. All right, so what I've done is I've plotted the Cartesian coordinate 1, -3, which is in the fourth quadrant. Here it is, right? 1, -3. Now, automatically doing that, I construct a right triangle, okay? And I know the radius is going to be square root of 10 by the Pythagorean theorem. The square root of, 1 squared plus negative, the square root of 1 squared plus -3 squared is square root of 10. So the radius, like for part A, the radius is going to be root 10. The next thing we need to do, though, is find the angle theta. We need to find the angle theta. So remember that the tangent of an angle, and I'm going to call my angle alpha here. Tangent is defined as y over x, the tangent of an angle. Okay. Therefore, alpha is the arctangent of y over x. And in this case, since y is -3 and x is 1, -3 is y, and x is 1. Okay. So this is how we get for this reference angle here. Let me make it red here, hold on. This reference angle, we get the arctangent of -3. So far, are there any questions? We're not there yet. We're not there yet. But are there any questions? All right. So the arctangent of -3, which is the angle for this reference angle right here in red, what's that equal to on your calculator? Tell me what you get. Make sure your calculator's in radian mode. And tell me what you get for the arctangent of -3. Who can chat it out for me? That's right. Thank you, Robin. -1.249, right? Now that's your angle in radian measure. Why can't we use that angle for theta? Why can't we use, and we know this red angle here, this red angle, since it's being measured from the clockwise from the x-axis, we know the angle is negative. Why can't we use it for theta? Why can't we say that our polar coordinate is √10 comma arctangent of 3? Wait, hold on. Now wait. No, I got to be careful. Yeah, why can't we say that our angle is our polar coordinate is √10 arctangent of -3? Why won't that work? Why would WebAssign not accept that answer? For this particular part A. I mean, it is a legitimate polar coordinate. Well, Josiah has one point. It's not, the number's not exact. That's going to be a problem because of the numerical tolerance. But there's another, that's a good point, Josiah. WebAssign wants exact answers, but there's another reason too. There's another reason also. Give you a little hint here. That's right, Robin. Theta has to be between 0 and 2 pi. So you can't have the arctangent of -3. That's a negative angle. That angle is a negative angle. But what we can do is make an adjustment. We can take 2 pi and, well, I want to be careful here. You can let's see here. You can take 2 pi no, hold on. One moment. You can take you can take the arctangent. I'm sorry, I'm doing the best I can here. You can take the arctangent of -3 and add 2 pi to that. So that would be taking the arctangent of -3 and adding 360 degrees, adding 2 pi. But, and that's fine, but as it shows in the picture here, 2 pi plus the arctangent of -3 is the same as 2 pi minus the arctangent of +3. So what I'm saying is that WebAssign for part A, if you had this kind of question, if it's not, I mean, it should accept the arctangent of -3 plus 2 pi. That's an exactly correct answer. But if it doesn't for the angle, alter the angle so that you have, so rewrite it as 2 pi minus the arctangent of +3. Okay, because the tangent is an odd function. So the arctangent of -3 is the same as negative times the arctangent of +3. And that's your answer for part A. Are there any questions on this? Any good questions so far? Okay. How do we know which root, let's see, just how do we know which root 10 is negative? Well, okay. So this is, we have the answer to the part A, but now for part B, we got to get to the negative part, where the radius is negative. If the radius is negative, you're going to have to use negative square root of 10, right? Because you know, the radius is the radius is the radius. So if the radius was positive radius was square root of 10, then you're going to have to, for the negative radius would be negative square root of 10. But then what you have to do is you have to find the right angle that will work. So if you take the, let me just do a clear here. It's in the recording. So we're good on part A, right? We're good on part A. Let's talk about part B. So what I need to do is arrive at this point here. I need to arrive at that point by going backwards. Well, if I draw a line, you know, if I think about the line, okay, this line here that I'm trying to delineate in blue, if I, hold on, let me try this. Shapes, line. Okay, so if I think about this line here, okay, I could put a point up here that's the same distance from the origin as the point xy that I'm interested in, the 1, -3. So this point here, the x, y coordinates. Whoops, hold on. Now I got to take the shape thing off. Hold on, go back to here. So the point I'm interested in is 1, -3. -1, 3 is the reflection point. I don't know why that did that. Gosh, I don't know why it does that. Hold on, I'm just gonna do this again. Come on. Okay, so let's get that off. Okay, so you agree that I have to write this. the xy coordinate here is -1, +3. So it's the reflection of 1, -3. So the idea is if I'm looking in this direction, if I'm looking in this direction here, if I'm looking in that direction, I'm looking at that angle. That angle is going to be the pi plus the arctangent of -3. I look in that direction, that angle, but move backwards, square root of 10. That's going to get me to the point I care about. Hence, for the polar coordinates where the radius is negative, polar coordinate, you're going to have -√10 pi. Well, pi plus the arctangent of -3 is the same as pi minus the arctangent of 3. So for part B, the polar coordinate is going to be -√10 and pi minus the arctangent of 3. Josiah, does that sort of, I mean, that we needed to do that part, but are you comfortable with that? Great, thank you. Is everybody else comfortable? Are there any questions? Any questions at all? Thank you, Francesca. Okay, thank you, Ryan. Excellent, excellent. Thank you. Okay, well, let me stop there, and let me give you some time to work on these H.1 exercises. I still want to talk more about them, and if I feel that I need to move the due date to, I mean, I'd like the due date to be tomorrow, but I still want to have it tomorrow, but there's still more I want to talk about. So if you know, let's just see what happens here. I think you can do most of them. Well, all right. Let me see here. One more thing I'll show you. There is one more thing worth showing. I think I should show it. So, and this will ensure that you'll be able to finish these by tomorrow. I showed you that the hardest part for students is graphing the polar curves. Okay, graphing the polar curves, like r equals 2 times the cosine of theta. And there are other polar curves also that they show in the book, like example 6. They show another polar curve that represents something called a cardioid. And they show you how you can relate the graphing of a polar curve to the graphing of a function in the xy, well, graphing like a regular trig function where your x-axis is theta and your y-axis is r. And I think there's value in that. But I don't think it hurts to show you how to graph a polar curve on your calculator. So let me bring up the calculator, and you bring up your TI. So let me go ahead here and find my TI calculator and make that available. Okay, one moment. Okay, so I want to, the third example that was in the notes here was graphing that r equals 2 times the cosine of theta. And we talked about that earlier in the ebook. We brought up the example in the ebook, okay, with the solution. And the way they do the graph is they pick points, and picking points is the way you discover how to graph things, right? But the calculator can also graph polar coordinates. So let me show you how to do that. For that example, r equals the what was it? The 2 times the cosine of theta. So I'll go to application here and go to the smart view on this. Okay, so here we are. We have our TI-84, 83 calculator. And what I'm going to do is, let me go to y equals and just clear these two things there. And then I'm going to go to mode. I'm going to go to mode. And the fourth line has, or fifth line has function on it. But I want you to arrow over in mode and click polar. Select polar. Okay. Okay, so enter polar. And let me see, it should just select it here. I don't know why it's blinking, but polar is what I want. So now let me go back into y equals. Good, this is good. And it has r1, so r equals a function of theta. Well, here r equals 2 times the cosine of theta. But if you click x, it's going to give you theta. Okay. Is everybody good so far? Getting their calculator into polar mode and then going to the y equals and typing in the polar equation. Okay. All right. Now we got to go to window. Got to go to window. Now your window is going to be a theta window. Not going to be it's going to be a theta window. So I'm going to let my theta min be 0 radians. Theta max, well, we only needed to go up to pi. So I will type in second pi there. And then for theta step, well, I never like to think about really, I normally like to think in terms of how many, like, on the, like how many values do I want? So for theta step, got to be a little careful here. See, it needs to plot a lot of values to get a good picture. So why don't I take the difference, between my theta max, which was pi, and my theta min, which was 0, and divide that by 100. So basically, I want the calculator to pick 100 values, 100 angles, and compute the radius at those angles and plot the polar coordinates for those 100 angles. All right, that's fine. And then, x min, x max, -5, 5 should do with the next scale of 1, and y min, y max, -5, 5 should do, because I already know a little bit what the graph looks like. And then I'm going to hit graph. But are there any questions so far on this? Any questions so far? Okay, so I'm going to hit graph, and it plots it. It plots it. It plots that circle. Now you notice I have a lot of real estate here that I'm not using, a lot of space I'm not using. So I can go back to window here and maybe make x min 0, x max 2, and let me see, y-min and y-max, maybe make them from -2 to 2, something like that. Okay. And just pick a little bit better window, and that's not bad. That's not bad. Okay, and that's how you graph a polar coordinate. That's how you graph a polar graph on your calculator. This will now certainly allow you to finish your H.1 exercises on time for tomorrow. How many think this is pretty cool? Maybe shout it out if you think this is kind of cool, that the calculator can do this. Thank you, John. Thank you, Josiah. Thank you, Robin. Thank you, Tyreek. Excellent, excellent. And, you know, in terms of the graph, you know, you can always hit trace, right? If you want to, let me see here, one moment. You can always hit trace and then, you know, be able to look at points. So I'm trying to see here. I wonder why my trace isn't moving. I'm not sure. Trace. I'm not sure on that. But let's do another one. Hey, let's do another one. I'm going to give you one for Valentine's Day. Okay. I'm going to give you a graph for Valentine's Day, even though it's quite a ways from now. What if you had to do the let's see here, the cosine of 2 theta. Okay. My window, I need to adjust it. I'll go from 0 to 2 pi. Okay, just because, you know, 2 pi is usually a good value. And then for my t-step, I'll take 2 pi minus 0, you know, theta max minus theta min divided by 100 points. And then x min, I'll let be negative, maybe -3. Y min be +3. No, x max. Y min will be -3. Y max will be +3. Okay, and we'll graph that. And you get a 4-leaf clover. Now watch what I'm going to do here. I'm going to do something really cool. 4-leaf rows, that's what they call it. Let me change this from -1 to +1. Okay, and x scale, I'll let be 0.1. Y min, I'll let be -1 to +1 with a y scale of 0.1. Okay, let me just look at the graph. Okay, that's fine. Let me go back to the window. So if you want to control how fast the graph is drawn, you can decrease your t-step. So I'm going to have 1,000 points. I'm going to take the theta max minus theta min and divide it by 1,000. And hopefully it'll graph it kind of slow. There. See that? It did it slow. And I can even do better here. How many of you might tell some of your, oh, hold on here. Let's do 10,000 points. 10,000 points. And do graph. There we go. How many are liking this? Give a thumbs up if you like this. Thank you, John. Thank you, Josiah. Thank you, Robin. Thank you, Tyreek. Yeah, see, you can, and this would be, thank you, Francesca. So this would be if you would have to pick a lot of values of theta to graph this 4-leaf rose. But if you did it, you might have to pick. Well, eventually you pick enough points and you get the pattern. Oh, Josiah says you're right. It's good for St. Patrick's Day. Yeah, yeah. All right. So very good. All right. Well, on that note, are there any questions? All right. Let me stop the recording.